Hello, math students. Welcome back to Linear Equations. This is lesson 22, and it is called Constant Rate Revisited. Our goal for today we will use constant rates to write linear equations and then compare the constant rates to see who is faster. The question that I want you to think about in this lesson is, how do you compare constant rates to determine which is faster? All right, so under the Things to Know section, the first thing that we would like to do is we would like to figure out who is faster in this activity. Max can run 3 miles in 23¼ minutes. Adam can run 8 miles in 61 2/10 minutes. Write an equation with two variables for each boy's running time. So what I would like to do is remember the process for picking an equation. And so I am just going to go with slope-intercept form immediately. But before I need to do that, I have to figure out what would be the constant rate that he's running. So right now I know that he runs 3 miles in 23¼ minutes. So what I would like to do is I would do miles per minute, and I know that he can run 3 miles in 23.25 or ¼ minute. So I want to know how fast he can run 1 mile. And so in order to do that, I would take 3 divided by 3 and I get 1. And now I have to take 23.25 and divide it by 3, because what you do to one side, you have to do the other. And so that would go in 7 times. 7 times again. And 5. So I now know that 1 minute takes him 7 3/4 minutes. 7 3/4 minutes to run 1 mile. Okay, so that's kind of helpful in figuring it out. And then we also need to know that we are going to identify that the minutes would be the x value and that the miles is the y value, because you have to have time in order to actually run. And so this would be the independent. The time is going to tick by. The minutes are going to go by whether you're actually running or not. So it's the independent variable. And then the miles depend on that, so that becomes the dependent variable. And so we identified that miles will be the y value and minutes will be the x value. And once we have that, we now can determine what the equation would be. So if we have y equals, and we know that the constant is that for every 1 mile it takes him 7 3/4 minutes, then we would know that our slope is 7.75 times x, and then that will be the equation with two variables that we need to use, because x would be the amount of time and y would be the amount of miles traveled. Okay, so that's Max's. Now we also need to identify or figure out Adam's. And so if we use the same process, remembering that the miles is going to be the y, the minutes is going to be the x, so we're comparing miles per minute. And we have here that Adam can run 8 miles in 61.2 minutes. And so we want to figure out how long it takes him to do 1 mile. So in order to get from 8 to 1, I divide by 8. What you do to one side, you have to do the other one. So I'm going to take 61.2 and divide it by 8. And I get, excuse me for my having to clear my throat. I have my cold again. It's not fun. And so then we get 5, bring down the 2, and that goes in there 6 times. 48, sorry. 5. So it takes Adam 7.65 minutes to run 1 mile. And so if we're to convert his into an equation, then again we know that the y represents the total miles and that he can run 7.65 minutes per every 1 mile. And so now we know that these are the two equations that represent the boys' running time. And so we have Max's is y equals 7 3/4 times x, and Adam's we have y equals 7 65/100 times x, and both of those give us the information that we need to determine whose would be faster. And so at this point, what we have to do now is we have to figure out whose is faster based on the slope that you see. And so what we're going to try to do with that is that we are going to figure out the steepness of the line. And so those are our two equations. Like it says, write an equation with two variables for each boy's running time, which we did. And then it says, graph the boy's running time on the graph. Use different colors to represent the lines. And then once we get done graphing, we have to decide who runs faster and then how do we know. Okay, so we can graph this. We just have to figure out where we would like it to sit. And so what I would like to do is I would like to determine what the y-intercept would be. And if you remember the rule for determining the y-intercept, that just means that x value has to be at 0. So if I take Max's, actually I'm going to stick, I thought I would change colors, but I don't want to. So y equals 7.75 times 0. And so when you get 7.75 times 0, you get an answer of 0. So that's very interesting because y equals 0. So now we know that the crossing point would be there. And then it says, well, what if we had, so y equals 0. So when x is 0, y has to be 0. Okay, and then let's try y equals 7.75 times 1. And so we get y equals 7.75. So on this one, it would be 1, 7.75. All right, that gives us our 2 points that we need. And so if we start with our first one, we are going here, and then it says to the right 1, and then up 7.75. So that's 1, 2, 3, 4, 5, 6, 7. And then 7.5 is 3/4. So I'm going to say about there. Okay, so that one right there looks like that is going to be Max's, okay, and Max is going to be dark purple. Okay, so now I'm going to take my ID, and sorry for my head being in the way if it gets in the way, but I'm going to make my straight line because this is a linear equation, and so we have this. So this, remember, is Max, okay, and now we're going to do Adam, and so we're going to use the same technique, and Adam's would be y equals 7.65 times 0, and so y equals 0. So again, we have 0, 0, and then we have y equals 7.65 times 1, and so y equals 7.65. So on this one, we have 1, 7.65. And so we have to graph that, and so we go over to the right one and then up to 7.65, which is less than 7.75, so I would say it's about here. So we have one here, and we have one here. And so when we connect those two, kind of hard on this graph because the graph is only slightly bigger. So this is Adam, when I fell off, sorry. But the lines look like they're exactly the same, but they really aren't, because if you look really, really closely, we have our two lines are in a different spot, but it's only very subtly. So this one is, the pink is actually here, right? And then the dark purple was Max's. So they're very, very close looking, but they are slightly different, okay? And so by plugging those in and graphing them, that allows us to see that they are only slightly different. And then the thing that we have to think about for who runs faster is that, well, for 1 mile, it takes Adam 7 65/100ths of a minute, and then for 1 mile, it takes Adam 7 75/100ths of a minute. And so Adam is actually faster. Adam is faster by 10 seconds, right? If you look at it that way. So that's kind of cool. And then how do you know? We looked on the graph, and it was hard to see from the graph. So I don't know if I want to say how do you know is by looking at the graph, but I would just say you compare the actual times. And so if he gets 1 mile done in 7 65/100ths, and then Max doesn't get it done until 7 75/100ths, then you know that Adam is done before Max. So the actual time shows who is faster. Okay, and so that's what we have to help us figure it out. So basically, the whole point of this lesson is, can you determine a comparison between two different things based on the information given? And we definitely can. The number one thing that I would say that you have to do is you have to be able to figure out what your unit rate is or what your slope is. And remember, unit rate and slope are the same things. So that's why if we go back to what we actually did, where we compared miles to minutes, we found an in common amount, and the in common amount that we found for this one is that we went for 1 mile. So that's what they have in common. And then we were able to compare the speed going the same distance. So 1 mile, it took 7.75 minutes, and then 1 mile, it took 7.65 minutes. And so that tells us who was faster. And because our graph isn't really broken up into itty-bitty sizes, it was hard to actually visually see that Adam was faster, but he is faster by 10 seconds. Okay? All right, so today we will use constant rates to write linear equations and then compare the constant rates to see who's faster. That's exactly what we did. How do you compare constant rates to determine which is faster? The way that you compare constant rates to determine which is faster is you have to have a common amount. And that's what I was talking about where I said, okay, well, let's determine for 1 mile. They have 1 mile in common. When we started this problem, we only know that Max ran 3 miles, and we only know that Adam ran 8 miles. So the commonality that we could find was, well, figure out what it would be for 1 if they're running at a constant rate, which it says they were. So once you can figure out a comparable amount of distance, then you can actually see who was moving at a faster rate. All right, kiddos? That's all I have for you today. Talk to you soon. Bye.